Hey there, ladies and gentlemen. It's time for our next math lesson, lesson 2.3, equate and compare to thousandths. So please write down the following I can statement. I can recognize equivalent decimals through using tenths, hundredths, and thousandths. And what I'd like for you to do, also remember to write that lesson 2.3 at the top of your math notebook page. All right, so let's go ahead and get started. One way we can think about tenths, hundredths, and thousandths is we can think of a meter stick. The meter being one whole, okay? So let's take a look at this right here. We know decimeters, and on a meter stick, those are represented by these large numbers here. Okay, so this is 50 centimeters, but it's also 5 decimeters, and there's 10 decimeters in a meter. Okay, so that would be tenths. We know there's 100 centimeters in a meter, so that would be the hundredths. And millimeters is thousandths, so that's just thousandths. So that's just a way to kind of get that visual reference to think about those different parts. Okay, so if we were going to look at 50 centimeters or 5 decimeters, okay, we can look at that as 5 decimeters, which is 5/10 of a meter, or written as a decimal, 0 and 5/10. 50 centimeters equals 50 hundredths, or 0 and 50 hundredths. Or it could be also 500 millimeters, which can be written as 500 thousandths, or 0 and 500 thousandths. Now, I did offer this up to my kids last year, and nobody took me up on it. But hey, if you ever have some extra time on your hand and you want to pull one of my meter sticks down in the room and count those to make sure there are actually 1,000 lines on that meter stick, go ahead. You are welcome to do so. You can report back to me with your very fascinating findings. Okay? What you have to recognize about these are all equivalent fractions and decimals. Okay? We talked a little bit in class last time about how we can eliminate those zeros here, and we can see by lining them up by the decimal point that the 5 stays in the tenths place all the way through. Even though we have different names for each of these with the zeros at the end, they still mean the same thing. They're equal to each other. Okay? So, there's another way you can do this. You can actually model these out if you'd like to. Okay, so we can take a look at this. This is a number line here, and the big sections here represent the tenths, and then the individual pieces inside equal the hundredths. You'll see there's 10 of these going across the page. So if we shade 6/10, and then we shade 2 hundredths, what does this equal? Well, one way we could represent this if we were going to do this as an addition problem is we could add 0 and 6/10 plus 0 and 2 hundredths, which equals 62 hundredths. Or we could do 0 and 60 hundredths plus 0 and 2 hundredths for a total of 62 hundredths. Either is correct because 60 hundredths and 6/10, they're equivalent. That's what I'm saying. All right. So then when we compare decimal numbers, there's a couple of things that we can use. We talked about stacking them by the decimal point in the last note, and I still highly recommend that. Okay. The other thing we can do is when we're comparing decimal numbers, we talked a little bit about this in class as well. When they're not the same length after the decimal, we can add zeros to decimal numbers. It does not affect or change their values. So when we're looking at this first pairing here, I've got 6/10 and 28 hundredths. Sometimes kids get confused when they look at these and they go, this has got 2 digits, it has to be worth more. Well, add the 0 over here and you quickly can see, oh wait, now I've got 60 hundredths and 28 hundredths. It's very obvious that this is worth more. The closer these numbers get to the decimal point, the more they're worth. So we could have compared these just by the tenths place. And because this tenths place is worth more than the hundredths place, we can see that 6 is more than 2, and that automatically tells us, whoops, okay, I got ahead of myself there a little bit. That automatically tells us which is larger, okay? Because that 6 in the tenths place is worth more than 2 in the tenths place. 6 dimes, 2 dimes. We talked about that in terms of money as well, okay? We'll look at this next number here. I've got 3/10 and 230 thousandths. Again, I can just stick a couple zeros on the end of that. Now that makes that 300 thousandths. 230 thousandths, 300 thousandths is larger. Another trick we can do is we can actually cross out zeros at the end of decimal numbers to compare. Again, it has to be decimal side. Don't do this on whole number side because that's going to mess everything up. We don't need that, okay? So let's take a look at this first equation here. I'm going to cross this out, and I notice that this is 2 and 5/10 and 2 and 5 hundredths. I can also, they're still not the same length. If I need to, I can stick that 0 on this number here. Now they're exactly the same length. I've got 50 hundredths, 5 hundredths. It's clear that that's the larger one on the left there, okay? On the second one here, I can cross off my 2 zeros here, all right? And now I've got 2 3/10 and 2 3/10. It was 2 3,000ths over here. Those are equal, okay? Mistakes to look out for.
Danger, Will Robinson, danger.
Yes, I don't want you to be in danger. No, no, no. Okay, so these are the things you have to remember when we're talking about decimal numbers of the small parts, okay? So, when we're looking at 17 and 9, okay, we know that 17 is greater than 9, but 17 hundredths is less than 9/10, all right? Because now we're on the decimal side of that equation, okay? Remember, if we just put a 0 at the end of that 9 right now, that'd be 90, and this would be 17. Pretty obvious, all right? 138 is greater than 73, but 73 hundredths is greater than 138 thousandths. Finally, 456 is greater than 8. However, 456 thousandths is less than 8/10. All right? It's all about the place value. You just got to remember that. Really important, okay? Place value in decimal numbers is the key. The closer it gets to that decimal, the more it's worth. All right, so here's some practice problems for you today. I need you to compare the first two with the greater than, less than symbol, okay? And then I just need you to write for 3, 4, and 5. I've given you them in somewhat of a word form here. It's not completely word form because there's numbers there, but I need you to write each of them out there as a decimal number. And we'll see you soon.